Question number 10. Whenever Lewis and Denver play a game of bubble on the computer, the probability that Lewis wins is 0.3. No game ever ends in a draw. So Lewis winning 0.3, Denver winning must be 0.7. Game 2 obviously will have, game 1 will have no impact, so it's still 0.3, 0.7, 0.3 and 0.7. Probability that Denver wins both is wins and wins, so that will be 0.7 times 0.7, which is 0.49. Question number 11. A rectangle lawn has a length 9 and width of 5. So a quick sketch shows that we have 9 along here and we have 5 along here. A builder is asked to make a path width x meters around the edge. So we're going to add a path around that is x wide on all 4 sides and also in the corners. So the 4 sides will be easy to work out the area because this rectangle here will be 9 times x because it's 9 wide and x. This one here will also be 9x. The 2 on the ends will be 5x. The difficulty comes with these corner pieces here. Now if we look at the corner piece is joined onto a path of width x that way and also a path of width x that way. So this corner piece here has an area of x squared and there will be 4 of them in the 4 corners. So altogether we have 4x squared plus 1828x. So the area will be 4x squared plus 28x. All at the corners it is possible to curve the outer edge of the path and still keep the width of the path. Find an expression for the area of this path in terms of x and pi. So we're still going to have the 28x initially because these 4 parts aren't going to change. What is going to change now is the corner. The corner is now going to become curved. Now we have x here and we have x here. Now this is part of a circle, so we're going to use pi r squared, where radius is x in this case. So this corner is going to be pi times x squared. Now this is only a quarter of a circle, so we are going to have to divide it by 4. However, at the 4 corners there will be 1 of these each time, which means we will have 4 of these, and therefore these 4s will cancel. So this time we will have pi x squared plus 28x. Table of values shows complete the table of values. So with these, if you're unsure, check one of the values they've given you to start with. Does this minus mean you do the squared first and then put the minus in afterwards? If you're unsure, check one of the values and make sure you get the answers they get. So 7 squared is 49, so this is going to be minus 49 plus 56 minus 12. So minus 49 plus 56 is 7, minus 12 is minus 5. For 8, we're going to get minus 64 plus 64 minus 12, which is going to give us minus 12. Then we need to plot this, so at 1 it's minus 5, at 2 it's 0, at 3 it's 3, at 4 it's 4, at 5 it's 3 again, at 6 it's 0 again, at 7 it's minus 5, and at 8 it's minus 12. And then because this is a curve, we need to sketch this freehand, not joining the points up. Obviously with a pencil you can rub out any wayward points, but I'm using a pen so you can see it clearer. Part C. Use your graph to write down the solutions to the equation equal to 0. So when it's equal to 0, that's along the line here, so the solutions are 2 and 6. Part D. Use the trapezium rule with ordinates x equals 2, 3, 4, 5 and 6 to estimate the area. So the trapezium rule is a half times by y0 plus yn plus 2 lots of y1 plus y2 plus y3 in this case. So this is a half of y0 is at the value at x equals 2, well that's 0, plus the value at x equals 6, so that's 0 again, plus 2 lots of the values of the ones in between, 3, 4 and 5. Now these were given to us in the table, so we know this is 3, 4 plus 3. So this will be 3 plus 4 plus 3. So this is a half of 3 plus 4 is 7 plus 3 is 10. So this is a half of 2 times 10. So this is a half of 20, which is 10. Question number 13. Given that y is inversely proportional to x squared, so y is proportional to 1 over x squared. Find an expression for x in terms of y when we know these values. So this is y is equal to k over x squared. When y is 10, x is equal to 12. So this is 10 times 144 is equal to k. So 1440 equals k. So then we plug that back in and we find that y equals 1440 over x squared. And that is our expression. Question 14. Sketch f of bracket x minus 2. Because this is inside a bracket, it means we move left and right. The minus 2 means we're going to move 2 to the right. So at the point 2, this will now happen. So the whole graph will have just shifted across to 2 and will now look something like that. It's purely a sketch, it doesn't have to be very accurate. Minus f of x means that whatever's above will end up below, but because we've got this plus 3, it also means it's going to shift up 3 as well. So this graph is going to, whatever's above will end up below, so that's going to go like that, and that bit there is going to go like that. Again, that's only a sketch, but that is accurate enough. Question 15, rules of indices. You need to know that a minus means this is 1 over 400 to the power of 3 over 2. You then need to know that 400 to the power of 3 over 2 means the square root of it cubed, or 400 cubed then square rooted. Square root of 400 is 20, so this is 1 over 20 cubed. 20 cubed means 20 times 20 times 20. So 20 times 20 is 400. Times another 20 will be 8,000, so the answer is 1 over 8,000. Part B, express as a fraction. So A equals 0.6525252. So 100A will be 65.252252. This almost all cancels apart from the very first one. Then when we subtract, we get 99A equals 64.6. 65.2 minus 0.6 gives us that. So A is 64.6 divided by 99, times them both by 10, gives us 646 divided by 990. Simplify and state whether your answer is irrational or rational. So we have 3 minus 5 root 2 times by another 3 minus 5 root 2. Using FOIL we get 3 times 3 is 9. Then we get minus 15 lots of root 2 minus another 15 lots of root 2. And then on the end we're going to get plus 25 times by root 2 root 2. 9 is just a number. This gives us minus 30 lots of root 2. And then root 2 times root 2 is 2, so this is 25 times 2, so this becomes plus 50. So overall we get 59 minus 30 root 2, and this is irrational because root 2 is never ending. Question number 16. The time taken to sew new buttons on a shirt was measured for 200 people and shown in a histogram. Use the histogram to calculate how many of the children took less than 50 seconds. So we need to use the fact that the frequency density was found by doing the frequency divided by the group width. We need to find the frequencies, so we have to do frequency density times by the group width. So the group width here was 20 times by the frequency density of 1. So the first block was 20 people. The second block we only have a group width of 10 and a frequency density of, oh sorry, that's actually 0.5, which gives us 10 people. This is going to be 1.5, so that's 15 people for that block. This block here, again the group width is 10 and the frequency density is 2.5, 3, 3.5, so that is 35 people. And then the last block, because we're only looking at less than 50, the last block again is 10 for the width times by, and the frequency density of this is 7.8. So that's 80 people, and then we are going to swap pens because that one's run out, and we're going to add these numbers together. So we've got 80 plus 35 plus 15 plus 10, so that's 105, 125, 130, 140 children altogether. Alternative way of doing it would have been to just look at the group that weren't, so that's 10 times by 6, so that's 60 that weren't, and then obviously that left 140 would have. Part B, similar thing for the adults. Find an estimate for the median. So if they asked 200, the median will be the 100 and 101st person. Now the 100th person is right at the end of this group, and the 101st is right at the beginning of this group, so it's reasonable to suggest that the median would be 50. Draw the histogram, so we need to find the frequency densities. So for the first one, we've got 20 divided by 20, which is 1. This one is 20 divided by 10, which is 2. 25 divided by 10, which is 2.5. 35 divided by 10 is 3.5. And 100 divided by 10 is 10. So from 0 to 20, we need to go up to a histogram to a frequency density of 1. From 0 to 20. From 20 to 30, we need to go up to 2. From 30 to 40, we need to go to 2.5, which will be that line there. Make sure you use a ruler every time, I'm just being lazy. From 40 to 50, we need to go to 3.5, so that's 2.5. So that will be 3.5 there. And then from 50 to 60, we go up to 100. And that's the histogram complete. Using the information parts A and B, do you think the adults are faster than the children at sewing buttons on shirts? Just give a reason for your answer. So if we look at the two histograms and compare, we need to say who was faster. So first of all, we can use either the median to estimate, or we can find other values, but I'm going to go with the median. So the median of the adults was 50, and for the children the median would have been less than 50, because again it would be the 100th person. Now there are 10 in here, there are 15 in here, so that's 25, plus those 35, which makes 60. Plus then these 80 would take us up to 140, so the 100th person actually would be in here somewhere, less than 50. So therefore the median for the children is a smaller amount than it is for the adults. So the question is no, the adults are not, because the median is higher for the adults.